Hi folks, this is Don. I'm going to take some time and go over some problems, common mistakes that I see a lot when I'm reviewing your homework and quizzes. And this is on Chapter 7, Sections 7.1 and 7.2, which have to do with the basics of setting up hypothesis tests and single sample test, usually for the mean or the proportion. And I want to review this person's work, and hopefully I am screening out his name so you won't see that. He makes a number of mistakes that I see too frequently in a lot of people's work. On this first problem, we are to test a claim about the population mean mu, and we're given sample statistics and alpha. And it says the claim is mu not equal to 6,000. Okay, let's focus on that for a second. And we have to first identify the null and the alternative. Well, remember, and you should use those graphics that I posted in the course, the tables that show you how to convert words into formulas. In this case, we're given the claim. It contains the not equal operator, and you must remember that the null hypothesis always contains a form of equality, and the alternative always contains operators that are forms of inequalities. Not equal is an inequality, less than symbol is an inequality, greater than symbol is an inequality. So since this is an inequality, that tells us the claim has to be the alternative. The null is always the complement of the claim. So if this claim contains the inequality, going back to the graphics I posted, the corresponding operator for the null becomes the equality. So looking through these six options there, we find here is the null containing the equality and the alternative the inequality, so that is the right answer. Then we have to calculate the standardized test statistic, and this person did that right, so I'm going to skip over that for now. But let's look down here at the critical value, and he got the wrong value for the critical values. Notice that we had two options there. The critical value or the critical values are plus or minus. Anytime the alternative contains an inequality, not equal, that tells you it's a two-tailed test. And again, go back to those charts and graphics that I posted. It's a two-tailed test. That means there has to be two values, critical values of Z or T, depending on the test you're running. So that's why the correct answer was the critical values are plus or minus. This person entered in just 2.27, and somehow that person made an error in calculating the critical value. But what I see quite common is people will not enter in the plus or minus for the two-tailed test, or they will mistakenly answer that it's a 2.27. The reason I'm thinking this person just was thinking of a one-tail and a critical value of positive 2.27, which is on the far right end of the normal curve, the person selected fail to reject. And you would fail to reject if the standardized test statistic is not in the rejection region. Well, minus 5.37 is way on the left end. That's a lot of standard deviations out there on the left end. It's well beyond minus 2.17, so it would be in the rejection region if you knew that there was a rejection region on both ends of the normal curve. But if you're thinking the rejection region is only anything greater than positive 2.27, then this test statistic minus 5.37 does not fall in the rejection region, and therefore you would get the wrong answer. So be really careful. Identify what the alternative is. That determines the tails of the test, which in turn determines the critical values. And if you're using the rejection area approach to solving the hypothesis test, that will determine whether or not you get the right or wrong answer. Okay, on this problem, it's another hypothesis test of a mean, and we're giving a lot of information. I'm not going to go over that for right now. What I want to concentrate on again is taking the time to identify the null and the alternative. And in this problem, the person did identify those correctly, showing that the claim was a greater than or equal, which is a form of equality, therefore it's the null, and the alternative contains the less than operator, which is the complement of this, which means that this is a one-tail test and it is a left-tail test, which should tell you that the critical value is going to be less than 0. It's going to be a negative value. This person answered positive 2.05. So they did the math right to get the 2.05 problem, but either they didn't realize that this was a one-tail, left-tail test, and that's the reason they got this part wrong. They also picked the wrong graphic down here, normal curve. They picked the one that corresponded with plus 2.05, and that is not the correct one. This was a left-tail test, so it should have been minus 2.025. So again, be really careful to think through what is the alternative, what is the null. Use the operator in the alternative to tell you, is it a left tail, which is less than, right tail, which would be greater than, two tail, which would be not equal. All right, here's another problem on hypothesis test, and it is really pretty simple. They give you this statement: according to a recent survey, 24% of college students own a credit card, and they want you to write the claim as a mathematical statement, which is the first thing we have to do when we're doing hypothesis tests. This person selected the proportion is less than or equal to 0.24. And that is just a misunderstanding of the words up here. 24% of the students own a credit card. The proportion of college students owning a credit card is 24%. That would tell you it's an equal, and that should have been the answer there, the equality. Because it's the equality, that means that it has to be the null. The claim has to be the null. And that's the second part of this question. The person being consistent with their mathematical statement, they're saying the null is less than or equal to 0.024, but that's wrong. Remember, the correct answer is the proportion is equal. So looking through these, the correct answer would have been the proportion is equal to 2.4, and the alternative is not equal. Then they have to identify the claim, and again, the person was following through, just not reading and not using those graphics I posted. They picked the wrong answer, being consistent with their first mistake. But in our rules and grading these things, I cannot assume that you were being logical, because there's a chance you could have just been picking answers. So it's so critical to read the statements, rephrase it so that it matches something in those tables I've shown, and do that, and then you can get the rest of the answers straightforward.